Matt Venn joins us today on The Siliconomist. Matt is a force of nature in open silicon. First, Matt's founder of Tiny Tapeout. It's a platform that has nearly 3,000 chip designs, put them into real silicon. And in the process, he's built what might be the most accessible on-ramp to custom chip designs that's ever existed. And second, Matt is the creator of Zero to ASICs course, which has taken thousands of engineers and students and makers from complete beginners to people who have actually taped out their own chips. So together, these two things form kind of this end-to-end pipeline. People learn to design, then actually build. No one's really pulled this off before. So excited to talk to Matt today. Welcome to The Siliconomist, Matt.
Thanks, John. Thanks for the nice intro.
You're based in Valencia, Spain. It's a global community that you've kind of built, and you're joining us from Spain today, right?
That's right, yeah.
Great. Can you tell us more about Tiny Tapeout? You launched in 2022. Is that right?
It might be, yeah, it might make more sense to start with the Zero to ASIC course. Now courses, I've got two, but it started off with a digital focused course. I was a contracting electronic engineer at the time and usually spending a day a week following my interest, keeping up to date with things. And I was also sharing as I was learning on social media because I discovered as a contracting electronic engineer, it's very important to build your network. So I went to a conference to present something, but while I was there, I saw something else, which was Tim Edwards presenting an open source microcontroller. And until I saw that talk, I had no idea that there was a possibility of doing open source chip design. And I had a chat with him. I checked out his flow at the time, which was called Qflow. And because I had some FPGA experience, I ran some FPGA designs through his Qflow tool and got my GDS layout. GDS is the files you send to the factory, a bit like Gerber files if people are listening who are used to PCB design. But my GDS files were created with an academic PDK, process design kit. So they're useful for learning, but you can't get them manufactured. And then I had a quick look at how much it was going to cost to manufacture silicon. And I was like, okay, this isn't for me then. But I did notice a lot of people were very interested in the open source silicon tools. And I got a lot of interaction on the posts I made sharing the GDS files. Normally, when you're making a GDS file, you can't share them because you've signed an NDA for the PDK and maybe signed an NDK for the tools. So at that point, it was quite rare to see chip layouts shared in social media. And then I was just very fortunate to have, maybe only like 3 or 6 months later, Tim Ansell from Google at the time announced this free lottery shuttle program where they would manufacture your chip design free of charge if your design was open source. So all I had to do basically was move to a different tool flow, move to a different PDK, and I was able to run the same design through, get GDS files back, but this time they were manufacturable because there was a associated foundry, Skywater in Minnesota in the US. And yeah, I saw the engagement. The people were very interested in that. I had my first chip manufactured. I did a presentation at a conference and I had a call to action, which was if you want to pay $500 to take a course on how to learn this, sign up here. And I got like 300 people signing that. So I thought, okay, I'm going to take a break from contract electronic engineering and start a course.
That's awesome.
I had a ton of experience doing science communication. So it was already, I'd not done an online course before, but I'd done lots of teaching. So yeah, created the Zero to ASIC course. We submitted on all of the Google shuttles until they end of life that. Mm-hmm. But I was already getting a bit annoyed at the lottery aspect of it because I wanted people to be able to pay for a ticket, and part of that ticket was a guaranteed tape out. And all I could say was, I will help you make a submission to the lottery, and if we're lucky, it will get manufactured. But I couldn't guarantee anything. And kind of Tiny Tapeout came out of that need.
There were MPW services before, I think. Were they not? They didn't fit the bill for what you needed to do?
Yeah, they were basically too expensive and too difficult to access as an individual.
Okay.
So yeah, there's CMC in Canada. There's Moses, maybe one of the most famous old school ones. And there's all the ones at Europractice and XFab. But yeah, difficult to access, difficult to work with them. They're generally not interested unless you're making big orders or making regular orders. And none of them you could target with open source tools. So you also had to find a way of getting hold of the end of the tools like Cadence, Synopsys, Siemens.
Zero to ASIC, born first. Tiny Tapeout, built to satisfy the need to send all the designs to the fab. 3,000 designs, 17 runs later. Is that right?
Something like that. Every time we run a shuttle, add another 300 or so designs. So it's a bit difficult to keep up with the numbers. But yes, maybe around 2,000 designs now, mainly from complete beginners. And so just to explain what Tiny Tapeout is, essentially is a multi-project wafer is a way of doing cheaper chip prototyping, because instead of the NRE costs are borne only by you or your company, you go in and share the NRE costs with 40 other people. So on Sky 130, the NREs are about $200,000. But an MPW where you just get only about 100 chips back, just like useful for testing a design, but you can't really use it for manufacturing at scale. You're only paying kind of $10,000 to $15,000. Tiny Tapeout is a multi-project chip. So we put, say, 300 designs onto one chip, and then we can spread that $15,000 cost among 300 people.
That scale, people are making their first chips. What do you make for your first chip?
Good question. We kind of see it as a bit of like the hello world of ASIC design. So the first thing we're encouraging people is just to do the most simple thing, just to go end to end and experience the whole flow. Because until you've done it one time, you don't really know what's involved. Especially true for more challenging stuff like analog or mixed signal. I always tell people just do a design with 2 or 3 transistors just to see what it's like, and then complicate out from there.
Is there the equivalent of the Arduino flashing LED for?
Yeah, I mean, that's a good one. For a beginner, a flashing LED, you can kind of build that in 5 or 10 minutes.
Okay.
And we have a set of, for Tiny Tapeout, we're really want to make it accessible for complete beginners. So we do quite a lot of workshops. So in that scenario, we want people to not have to download any tools. So there's another good thing about the open source tools and PDKs open source PDKs without an NDA is you can, through the tools that we've created, do everything just through a browser. Don't need to download anything. So that makes it possible to do, say, a workshop with 100 high school students, and they just have to bring a laptop.
So a lot of this has been done online before, but you're starting in-person workshops now as well? Kind of alluded to that just now.
Probably done, I don't know, 15 or 20. I've already done 4 this year, and it's only March.
Wow. Jeez. And do you round up a group of high school or even university students into a room?
We usually get invited. So a university, typically the way it's worked so far is a university reaches out and say, we want to do a Tiny Tapeout workshop.
Okay.
And then they provide the venue and they do a lot of the outreach. And then we train the TAs, which are usually volunteers from the university. Usually the reason the university is wanting to do it is because they're wanting to recruit more people into their microelectronics programs.
Okay.
So the workshop is just seen as a fun, easy way to get started that is going to result in 100 people doing their first tape out.
This is fascinating. So, and just to backtrack a little bit, when they're doing designs, things are open source, but you've talked about there's an IP library that ships a very tiny tape out chip. Is that right? What's happening there?
So one of the common misunderstanding is that people think that when they get their chip back, it's just going to have their one design on it. But it's a multi-project chip. And with microchips, every time you make a change to the design, you have to if we wanted 100 different chips, we'd have to pay 100 different chip costs. So the whole reason that Tiny Tapeout works is we put those 100 designs all on one chip. And that means that when you get your chip back with your design on it, you also have 100 other designs on it.
Okay.
And you might be a beginner, but we have people doing Linux capable 5-stage pipeline RISC-V CPUs on there as well. So you will also get designs like that. Or we have like the principal IC scientist at Nordic Semi doing like hobby level A to D converters, and you would get that. Or
Also sitting next to my Hello World LED blinker, the Nordic Semi's got the latest open source idea, I guess, in Bluetooth.
A to D converter.
I get one of those too.
You get all of that as well. So
Yeah.
the idea of so you get a lot of other people's designs for inspiration, and so that you can kind of test other people's designs. And we have, like, we ran a demo scene competition recently. So who can make the most impressive audio visual demo in a given tiny area, like about 16,000 square microns. So I've got this on my desk at the moment because it's one of my favorites, like the Matrix style digital rain. That was one of the winners. Fits in a single tiny tape-out tile. So that's on the chip as well. So as well as all the random designs that we get from all the people making use of the platform, we are also working on curating an IP library that includes a RISC-V CPU, an FPGA that you can run very simple digital designs on to check your design is going to work first, a analog FPGA for people who want to learn analog microelectronics, and then a kind of best of like all the coolest designs that have been submitted over the 20 or so chips that we've done so far. So there's always this package of good stuff that you get on every chip. And that's something that we're working with universities, because as well as them using the platform for their undergrads to do tape outs for the first time, they may also want to do like a ASIC laboratory where they need to bring up a design or analyze why a design is broken, or use the analog FPGA to help students learn the basics of analog microelectronics. So having them always present on every tiny tape out chip, it makes it into a useful lab tool as well.
Yeah, I can imagine even if my design doesn't work, I get something that's working on there that I can go ahead and plug in and play and still see the whole thing through. That's really It's a nice consolation prize if I mess up the first time. I was reading somewhere your user base is shifting. We talked about like education, but are there more industrial customers or startups coming online? Something like some of 38% of your orders are now.
We're just actually due to do the next yearly Tiny Tape Out user survey. But it is kind of the very early runs were almost entirely amateurs and hobbyists and makers. And then we quickly saw a big growth in academic. So kind of 35% student, 35% professor. And then we've seen this growing segment of people who identify as coming from industry, and reaching out to those people to talk about why they're interested. A lot of the time it's because if you're doing chip design professionally, you're not allowed to use the tools for anything apart from what your company is working on, what your boss is telling you. This is because the tools are so expensive. There's a huge amount of contention, so you're only allowed to use them for work-approved stuff. You can't publish anything that you're doing because you've had to sign all these NDAs and so on. And so a lot of these people might be very gifted circuit designers, might have like interesting ideas, might be very creative, but they have no outlet for their skill. It's like being a professional musician in a band, but then never being able to play anyone your music or write your own music or play it to your family or have fun with it. So those people use non-NDA tools, don't sign anything. They can try out an idea or an experiment, submit it, get it manufactured on real silicon, and then test it.
Gives them a creative outlet. Speaking of tools and sort of the tooling, I also read somewhere like you want to make this as easy as, there's the analogy of Gerber's to PCB, right? And you want to make it as easy to get something together and put out there as it is for a PCB now. How close is this whole process to that? Like, Are there two or three big friction points or something standing between that?
I think we're pretty close, maybe even easier because you don't need to download anything. Although there are some online PCB design tools now, I think. What we do with high school students is we get them to do digital design by schematic entry, the old school way. So they're basically, it's a bit like the schematic entry for a PCB design. First you've got to draw your components and wire them all together. So you do that, but with standard logic cells like AND gates and NAND gates and NOR gates and whatnot, flip-flops. And one reason why I'm keen to do that instead of moving straight to a hardware description language like Verilog is because most people that we work with have already had some programming experience, maybe with Python or JavaScript or something. And when they see Verilog, they just can't help but get into the mindset that it's a programming language. So I really like them to first draw something very simple, then want to do something more complicated, and then get immediately frustrated. Like, this is really annoying. I'm not going to draw out 100 flip-flops. And then you're like, ching, now's why you use a hardware description language. But just remember, this hardware description language is describing that circuit that you drew. It's not a sequential programming language. And I think that kind of helps people get a little bit onto the right track of thinking about hardware design using a hardware description language. So a student does that, draws a simple circuit with, we use this tool called Walkway. And then we basically have a GitHub Actions flow. So they use one of our GitHub templates. GitHub Actions basically is an automated run. When you commit anything, it spins up a virtual machine and installs the PDK and the LibreLane ASIC flow, fetches we have a Verilog API for Walkway, so it can dump out the circuit design as a Verilog netlist, reads that in, runs it through the pipeline, and then you get your GDS file output that you can browse in as a 3D viewer. And then you've also got the GDS files that you need to submit into Tiny Tapeout to get it manufactured. So I would say, yes, as easy as doing a PCB. But the hard part is kind of coming up with some kind of, you're not going to really do anything probably that you're going to be particularly proud of with Walkway. You're going to move on to a hardware description language. And then that's the friction point, is how do you learn a hardware description language? How do you do something cool with a hardware description language for the first time?
Well, one of the cool things that I was talking to Tim earlier from Waferspace. One of the interesting things that he brought up was because the price point goes so low, it's not that you don't need verification, but you need maybe less verification. There's not as much of a requirement maybe as you see in industry, right? Like, because it's $200 rather than tens of millions of dollars, right? Yeah. And so that kind of maybe changes the paradigm. That's not to say that there's not good verification going on, but just like when PCBs got super cheap to make, you could kind of spend a little bit less time, maybe.
Yeah.
Double check.
I do see that one of the major differences between hardware and software is you get that immediate feedback with software. And if you have a 2-week wait in the loop, like for circuit boards, if you have to do 4 or 5 respins because you weren't paying attention, that's really annoying and wastes a lot of time and energy. And that's even more true with an ASIC where you're probably waiting 6 or 7 months. And it's pretty disappointing if you wait all that time and then a thing doesn't work.
I can imagine.
I think, in industry, it's like about 50% of the budget is spent on verification. So I don't think it's anywhere near that with people doing stuff with Tiny Tapeout, but
still matters. Yeah.
Matters. Load it onto an FPGA, check that it works. Write a simple test bench. If you write a test bench, that will automatically get run as a gate level verification as well. So that kind of, if you've got a test bench that has any kind of decent coverage at all, and it works on the Verilog and it works on the gate level netlist, you're like 95% certain the design is going to work as you wanted it to.
I saw that Tiny Tapeout is collaborating around, partnered with Swiss Chips. That's right. We're partnered with Swiss Chips. And it looks like Swiss citizens can get a design fabricated chip for free.
Yeah.
So like this whole sort of human capital effort that you see different governments putting into making semiconductor engineers and semiconductor people now. You've got a kind of a front row seat. So Swiss chips, I've read a little bit about China's one student, one chip program, which has been going on for a while. The EU Chips Act, NSF's chip design hub in the US. Almost every major economy now has launched some kind of national program to build a chip design workforce. To read on how any of these programs actually differ from each other, or if they're pointed towards success. Are they sort of solving the same problem, do you think? Or
Good question. I've paid most attention to the workforce development stuff. So both the EU and the US Chips Act, they have quite different numbers, but they're both saying that kind of by 2030, there's going to be like a deficit of 200 or 300,000 people in the semiconductor industry. Now that is across people working in fabs as well as doing the design side of thing and verification as well, which is obviously crucial for when you're blowing a lot of millions of dollars on chip design. Personally, I think that chip design or chip manufacture is so reliant on global networks. It could, like things kicked off in Silicon Valley. Okay, fine. They mostly did most of the stuff there in that one place, although I'm sure they were still getting a lot of their raw materials and chemicals from other places. And they were definitely very dependent on immigrants doing a lot of their labor stuff, especially for the mass production in the early days. But now, if you look at global supply chains for modern semiconductors, it is literally like these chips have visited 50 different countries and many times repeated and cycling and over again. Or like the raw materials all come from different places. There's like individual mines in America or in Spain that are really crucial for various aspects of it. So personally, I think better to focus on global trade and with other countries and companies to do chip design rather than try to do it all inside one country's borders. That might also help stabilize things a little bit, maybe reduce a bit of the fighting.
I've seen some people throw great graphics up that show that a chip goes a few times around the world before it's ever completed, from design to all the materials and everything that sort of like goes into it. So I don't think anybody, no matter how hard we try, is going to capture all of that and own all of that. But it seems like everybody realizes how critical it is maybe to have a piece of that industry, and the best way to train people, I guess, is up in the air right now. But it's kind of
so I guess my opinion, like there's a lot of the money is being spent on fabs.
Yeah.
So like America or I think there's a new AMD fab maybe in Germany starting. But these things are kind of 20 billion, they're huge investments. Yeah, I guess I don't really, the politicians woke up during the chip crisis in COVID times, but I guess I don't really buy the story that every country should have their $20 billion chip fab. And it's extremely difficult to do. And also, didn't we already learn that, TSMC do it great? Why not just work with these guys?
Yeah, relocating a TSMC fab to just about anywhere is a tall order.
Yeah.
Probably not the most efficient way to get a piece of the supply chain, but
I think there's plenty of room for specialization. It's one of the most specialized industrial fields I think there is. So there's plenty of opportunity for any country to get involved where they want. So I guess also in terms of just accessibility, me as an individual person trying to make a small change, it seems like much more likely that I can make some kind of impact on workforce development than trying to build a fab somewhere.
Yeah.
So that's what I've focused on. I think people should focus. There's also, we can get a little bit into the Moore's law. It's interesting to me that people still are saying that Moore's law is ongoing. It seems very clear to me that it's not. Or, okay, if you want to disregard the amount of money or effort it takes to get that next doubling, then okay, maybe it's still going on and might go on a couple more steps. But EUV, I read, took 10 trillion to develop. That's a lot more than going from, say, 55 to 22 nanometers.
There are definitely different wavelengths that they can drive down to for some of the direct write and the X-ray stuff that folks are working on may lead to more improvements, but we're getting pretty close to how spaced out atoms can be there, right?
Yeah, I
So
mean,
your
the
next
minimum
performance improvements
dimensions of
are,
the most
yeah,
recent MOSFETs are like 2 atoms thick or something on the oxide layer. So, okay, how are you
yeah.
going to make that smaller?
Well, I mean, you can squeeze out more performance maybe with specialized design, like more and more specialized chips, new
That's it. Yeah,
materials, packaging. So
yeah, yeah. I
it's no
think
longer
the
a one trick pony, right? It's like it's got to
the
be all the
gains are going to
tricks and
come
all the
from these other
ponies.
places. Yeah, that have
Yeah,
been not considered, or they like when things are easy to go to double, then
yeah,
great. We'll plan our businesses and rely on that. But now it's a lot harder. People are thinking more like outside the box, and I think you already see this with, say, the Mac silicon. Those chips are not CPUs anymore. They contain GPUs and accelerate like multiple different types of accelerators, as well as many like CPU cores. And so I would say that there's a huge amount of opportunity in more custom chips
yeah.
where it becomes more and more likely that you're going to squeeze out some extra gains by doing more custom stuff. But then to do that, you need many more chip
More
designers,
chip
and
designers,
also
right?
maybe chip designers who can work in smaller teams or be more creative or take more
Hmm.
risks. So
Hmm.
that kind of ties into my argument where I think workforce development is a great place to spend some cash, and also where I'm not denying that the proprietary tools are way, way further advanced and you're going to get much better quality of results, especially on the most modern nodes. But,
Yeah.
if you going back to Nordic Semi, they built their IoT dominance on chips all made on 130 nanometers. They only just moved to a more modern, I think they only went down to 90 or 55 like in the
Wow.
last couple of years. So there's still, you can build an IoT chip with a radio, with like
Hmm.
sensors, with Bluetooth, with A to Ds and D to As, all very nicely on 130 nanometers. And you can prototype extremely cheaply. And you can design all this stuff with open source tools. So I think, what if we had 10 times more chip designers that didn't have to work in these massive mega corporations like Apple and Broadcom and whoever else?
We were talking a little bit about supply chain there earlier. Roll back at least a year ago, Tiny Tapeout was dependent on on eFabless, and there was
Mm,
eFabless shut down like March 2025. I know that left a few Tiny Tapeout projects sort of in limbo or stranded for a little bit. I'm sure that took quite the pivot on your part. And I sort of roll back looking at last year, the map was Skywater, eFabless, Tiny Tapeout on top.
yeah.
And now you've added new foundries.
Yeah.
Skywater has been acquired. IHP in Germany's in global foundries through wafer space. You're running on these multiple processes. On one hand, you've got the multi-foundry ecosystem. It sounds more resilient, like more ways to pivot the next time something goes wrong. Or does that end up like fragmenting everything for you? The tooling and the community and the PDK
Yeah.
development. Does that
Yeah. Good question.
set you
Yeah.
forward or set you back?
We were lucky that we were already working with IHP and Swiss Chips. Swiss Chips were funding the work to adapt to IHP. So when eFabless went out, we already had done 2 experimental chips with IHP. So we were relatively close to running a paid service. And I spoke to many, many MPW service providers and got basically nowhere with any of them. It's very difficult to come up with a way to work together. They're very used to working in a kind of traditional way, I think.
Is that because of their protected IP? Is that what was a sticking point at some point, or were there other hurdles?
One is that an MPW run is typically 40 chips. That's like a more
Okay.
typical number. 40 is a bit low for Tiny Tapeout. That means you're only going to be able to send chips to 40 different people. We typically need at least 100.
Okay.
One is we didn't realize how cheap eFabless was. It was about $500 per square millimeter.
Hmm. Okay.
And that's the quotes that we were getting back from people, I won't mention any names, but they were like often 4 or 5 times that amount of money, and there didn't seem to be any room really for negotiation.
Okay.
And not even after trying for a long time. So we continued with IHP. Chip Foundry rose from the ashes of eFabless and offered their eventually the same named process, Chip Ignite, which is 50% more expensive. It's 15,000 instead of 10,000, but it's still $600 or $700 per square millimeter, which is still a lot cheaper than the majority of other NPWs. And you being able to continue to use open source PDKs makes things just a lot easier. And then the GF180 PDK was actually published way back. Like Google ran 2 free lottery shuttles on there before the program shut down. So we knew it had been done, but there was no NPW service that would accept open source designs. And then that kind of changed with a university project from Synopsys and also Tim's Wafer Space. So now we're working with, like you say, 3 foundries for more resilience. But you're right. It is more fractured. But when people ask me, when do you think the first kind of commercial open source chips will come out? And it's I think the answer to that can be quite nuanced, but just to look at one aspect of it, you can't make chips without a strong IP library. If you look at how people make chips today, they buy in enormous amounts of IP that does all the difficult, certainly mixed signal stuff. Unless you're a nice design house that is specializing in mixed signal or analog stuff, most people are going to be buying their USB PHYs, they're buying their Ethernet PHYs, they're buying their A to Ds and D to As, they're buying their DRAM controllers, and the thing that they're going to be making is tying it all together, a lot of people buy their CPUs off ARM as well. So a lot of it is, there's like some bit of secret sauce, but a huge amount of stuff is being bought off the shelf. So how can you do a useful chip that has some value in the industry without having a lot of IP to choose from? The most important IP, stuff like SRAMs and A to Ds and D to As and PHYs, they're not easy to develop and they take some time to get right. And you need multiple cycles of testing and characterization that all takes work. And then now suddenly someone who could kind of made that commitment to developing something like an SRAM or a ROM, the supply gets cut off. They can't get their chips back. They can't make new ones. That's devastating. And then we did get access to Skyback. So we were able to pick up a bunch of these projects in development, but they're like all the difficult, complicated stuff is mixed signal, and that stuff you can't just port from one PDK to another. You have to do a lot of redesign. So the fracturing aspect that you mentioned is real. There's different levels of foundry IP, like IHP have much better SRAMs that are available as part of the PDK that we don't have with Skywater. There's still a lot of stuff missing, and all that stuff has to be created by the community and then maintained by the community. And that's a huge ask. And I think that's an ongoing, unsolved problem in the world of open source chip design.
Yeah. I hope that with more people getting access to it, more people working on it now with the lower price and with your innovative kind of process, that maybe there'll be just more people that are available to help work on that and build those IP libraries out.
Yeah, they can go into the Tiny Tapeout IP library. So we're constantly manufacturing them to make sure that there's some kind of continuous integration, that they're always being tested, always being used, always being measured. Basically being able to rely on it so that you can use it as a library rather than as a risk.
So you're a quintessential entrepreneur here. You've had all these bounce backs and somewhat indestructible. What's Tiny Tape going to be doing in 10 years? What does this look like? Is it still an educational platform, or has it become something like a low volume ASIC foundry service on its own? Or does it matter
question.
which?
Yeah, I don't think it matters really. I mean, I would think one inspiration was looking at what the same story that happened with PCBs, that parallel has come up already in the conversation. When I was doing my first PCB designs 20 years ago or whenever, it was a big deal for me to send off something. I would, and I would have to often call somebody up, have a conversation, get a quote, then send files somehow, FTP, I can't even remember, and then get, wait for weeks and weeks and weeks, and then get like maybe a bunch of boards back with an expensive mistake. Actually, my first ever commercial PCB that I did have a mistake on it, which was annoying. And then with the advent of services like OSH Park, Perfect Purple PCBs, still providing a great service. They were doing aggregation on the big size PCBs that they do, aggregate 100 or 200 PCBs on there, and that made it much more accessible for low volume PCBs, and that really opened things up for more people to do it as hobbyists. And I think we'll see the same thing. I mean, I don't think we'll never get as fast as PCBs. It's very unlikely you're going to get semiconductors in a few weeks. I think hopefully with wafer space, with global foundries, we might be able to get down to 3 or 4 months, but there's still a long, long cycle time. And the longer the cycle time is, the longer the learning loop is. But in terms of where we're going in the future, if Tiny Tapeout is established as the OSH Park of the future world of amateurs and beginners getting access to chip design, and I would include, one of my dreams is that it's a lot of the academics that we see are people, and also coming into my course, are people who studied this at undergraduate level, but they never got to do a tape out, and then they come on my course just because you get a free tape out as part of the course. If we can get so that all undergraduates studying microelectronics do a tape out before they do a PhD or move on to industry, I think that would be a big win. Even if you're doing something simple, making it that feeling of when you're really committing, you've got to hit the deadline, you've got to make the tape out. There's no going back from it. That means something. It's different than software where you release some crappy, buggy app that you then fix as people complain about it. You have to get it right, and you commit to it, and you send it off, and you can't change it. That's a different feeling completely. People should go through that before they spend $20,000 on a PhD tape out, or join a team of 100 people doing a $20 million tape out.
So it's much better spend than even a textbook, or certainly a couple of course hours. So if
maybe
that's
a couple textbooks and a tiny tape out, that'd be a good division of money.
You got to get in, if you want the US, you've got to get in on this student loan hustle there, right? Like you've got to take FAFSA and let people put themselves in debt.
No, tiny tape out is cheap enough so people can do it on a credit card.
Well, I think I was listening to it was the Amp Hour interview where you were talking about, you have this growing kind of list of people that have done a tape out, right? It's a great, should pivot into being a hiring platform or something. It's a huge
that is something we're looking at.
Opportunity there.
The competitions that we run, we're looking at sponsor. We want to make it so. $150 is, that's 100 times cheaper than it used to be to do a tape out. Okay, you have the limitations of what tiny tape out is. You've got small designs and limited metal layers and limited IOs and so on.
Yeah.
But 100 times cheaper means 100 times more people can do it, maybe. But there's still a lot of people in the world that $150 is still a lot of money. So one thing we do is you can order area on the chip, but you don't order the chip, and then we can test it. So you, as a Latin American beginner chip designer, could still publish an IEEE paper with silicon measured results, but only have to pay $50 or so. And with the competitions, we try to make it so they're free to enter, so you don't have to pay anything. So we're always looking for sponsorships on the competitions to pay for the silicon area, and people who hire creative, inventive engineers trying to squeeze the last juice out of these constrained problems kind of lend themselves to getting creative. And I think the winners of the competitions would make very good hires. So as a hiring platform could work out pretty well.
Yeah. For anybody out there hiring silicon engineers, you've got to cost-effective way to find some good ones. Well,
Yeah.
Matt, Venn, thank you so much. Tiny Tapeout, thanks for joining us. Thanks for inspiring so many folks to go into silicon and get started. If people want to hop in on the silicon train, where in your empire should they go first?
Check out my in-depth digital and analog course that's got a great community and has a step-by-step journey to take you all the way through to holding a chip containing your design in your hand at the zero-to-asic-course.com.
Okay.
And then go to tinytapeout.com, watch the video and scroll down a little bit on the page to see when the next shuttle is.
Okay.
IHP shuttle sold out much earlier than expected, but the Skywater one is open now and tapes out in May. And with IHP, Skywater and Global Foundries, we should be running 9 shuttles a year. So plenty of opportunity to get involved.
Cool. Thanks, Matt. Forward to seeing you soon.
Thank you, John.
Thank you.